if at any point you think that it is preferable, feel free, jump in and ask me questions. I do not prefer to be the quote unquote sage on the stage. I like a lot of dialogue. I like a lot of discussion, and I love all of the interactions that I can have with each of you, whether you are a teacher or whether you are a student. So just like what Lou was saying, I taught high school physics, particularly AP physics, general physics, and freshman ninth grade level physics for about 5 years in the state of Kentucky. I taught some college, some courses in college for future science teachers, and I am working currently for the Educational Testing Service. As you all know, they are the individuals who end up writing the exam. But let me just preface this from the beginning. I've been working on AP Physics for the past couple of years. But for about the past year, I've really been involved in the development of test questions for the next generation science standards assessments. That's kindergarten through 12th grade for the states of California, Maryland, and Tennessee. So I do not have the answers to any of the questions that you may have about what you may take the test over, and I would not divulge that information even if I actually did. So with that said, we have a couple of different types of activities that we're going to go through today. We definitely want to go back, look at the mock exam that you were, hopefully that you had a chance to take week or two ago. And we're actually going to look at some student responses, because I think it would give you a really nice, clear idea about what the expectations are in terms of earning the points that need to be earned in order to maximize your score on the AP exam. If we have any time remaining, then what I would like to do is look at some of the released 2020 AP Physics 1 free response questions. Now, these were released about 2 weeks ago. And what I really like about these questions is they are going to follow the format of the types of questions that you'll be expected to take this year. Because as some of you may already know, just because of the pandemic that's taking place, the format of the exam is going to be slightly different than it has been in the past. So with that said, we're going to be with each other at least for the next hour and a half. We'll see if we need a little bit more time after the fact, but I'm so glad that all of you were able to join us today. So with that said, let me go ahead and share my screen so that we can begin our study session. All right. Please, 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 if someone can just let me know when you can see my screen, that would be very helpful to me.
You're good, Kyle.
All right. Thank you very much, Lou. So first and foremost, do not forget that your exam is going to take place this Thursday. That's Thursday, May 14th, 2020. For those of you who are on the Eastern time, that's going to be 4 o'clock. For those of you on Central time, that is going to be 3 o'clock. Now, with that said, I'm not going to necessarily go through all of the ins and outs involved in terms of preparing for the exam as you sit down on exam day. But one thing that I do want to mention is that the AP Physics C, I think it's the mechanics exam, was given today. And I do know that out of the 55,000 students who had an opportunity to take that test today, approximately 2% of those students reported that they ran into some issues in terms of submitting answers and or uploading their responses to the platform that needs to be used. Now, with that said, this is all secondhand information. I was not in the room with those students as they were taking the exam, and this information is being posted online by other AP Physics teachers. So here's one thing we want to make sure is do not be the 2% of students so far who have had issues with uploading the exam. I know that there are a lot of information available out there in terms of the best types of devices to use in order to upload your responses. I know that there are specific ways in which you need to upload your responses, and I know that there are situations where some teachers are advocating that you type your responses out, copy and paste them into the boxes, or you end up typing your responses into a Word document that you can then upload to the platform. Now, with that said, I have nothing to do with the development of the platform. That has nothing to do with the Educational Testing Service. And clearly, because all of us are kind of outsiders in that platform, I don't have any questions or any answers to any particular questions that you might have concerning the platform. But with that said, there is a lot of information out there. It is very important for the teachers that are on this call, for the students that are on this call. Please go through that information as meticulously as possible. Prepare yourself to take that exam at least an hour before it starts. That way you have the most up-to-date software. All of your devices are working. You are in a location that is secure internet service, and you are able to just sit down and concentrate on taking the exam itself. A couple of other comments, though, that I do want to recommend to you is that I do know for a fact that the College Board is out there on different various social media websites looking for situations where students are cheating on the exam. Now, I know that no one on this call would ever cheat on the AP Physics exam, but you can at least take this information and maybe tell some of your friends who are not on this call, definitely don't cheat, because I've already seen instances where scores have been canceled as of today before those scores were, or before the responses were even scored. So please, please, please keep that in mind. So you're going to have two types of questions on the AP Physics 1 exam. You're going to have a long free response question. This is called the qualitative quantitative translation question. You're also going to have the paragraph or argument short answer question. Now, both of these questions are going to be written in such a way that you are not going to be required to write any type of physics equations. You're not going to be expected to type out physics equations. You're not going to be expected to carry out long derivations or calculations to find unknown quantities. These exams are going to require a lot of mathematical thinking, but let me just be perfectly clear that your answers will need to be written in a prose style, P-R-O-S-E, prose style. Of course, we're all pros in physics as well, but your responses will need to be written in sentences. That way the readers have a clear idea, and readers being the people grading your exam, have a clear idea of what you're trying to communicate. So don't think that you're going to have to type out long, extraneous, crazy equations on this exam. That's not the point. Another thing, I want to calm your fears right now, because you're going to see this online as students start posting on social media about their experiences taking their other AP exams, whether that be AP Physics or whether that be other AP exams as well. They're going to say, I did not have enough time to complete the exam. And let me make a promise to you right here on this call. It is intended that these questions be designed so that it probably will take you longer than the allotted time to answer all of the question parts. Why is that? Number one, obviously test security. We're trying to make sure that people are not cheating on these exams. But also, since there are only 2 questions that are going to be on this exam, we need to provide as many opportunities as possible for you who are going to take the exam to demonstrate that you actually know something about algebra-based physics. So don't be scared if you open up a free response question and it's got parts A through K. Yeah, that's a long free response question, and it's going to be difficult for you to get through that entire question in 40 to 45 minutes. But again, you can make a 5. You can make a 5 on this exam and not answer every single question part. They are designed that way. So don't try. I mean, you're going to have to rock and roll when you open up these questions. You're going to have to get to it. You're going to have to start answering the questions. There's not going to be a lot of time for lollygagging and thinking quite a bit about your responses. This exam is designed for you to demonstrate whether you know something or whether you don't know something. But on the same token, as someone who actually has a lot of experience writing these types of questions, whenever I sat down to take those 2020 sample free response questions that were released by the College Board, I found myself struggling to answer every single part in the time allotted. And that was without really thinking about the questions themselves. So if I really struggle with that, you are too. So keep that in mind. Don't let that stress you out during the exam. I know that this is a time where you can have a lot of anxiety. I know that this is a time where you can get kind of scared. And I know that this is a time where you can look at a particular question part, you get frustrated, and then that causes you to not do as well in other parts. Each part is going to be designed so that you can answer it without the other parts being answered. So even though there's one question, parts A through K, treat each individual question part as its own individual question that can be answered without the other parts. That should give you a lot of hope. So if you get to part C and you don't know how to do it, go on to part D. If you don't know how to do that one, go on to part E. If you don't know how to do that one, go on to part F. Now, if you don't know how to do part F, I'm getting a little bit worried about you. You should be able to know at least some parts of some things. But I digress. Keep that in mind as you're taking the exam. So with that said, does anybody have any questions for me before we actually get started and look at sample response questions from the mock exam that you took? I'm not seeing anything in the chat window, but feel free, if you want to chime in the chat window, if you want to chime in with your voice, please feel free and ask me questions. Teachers that are in the room, that includes you as well.
We've got radio or silence, Kyle, so you're on your, take it away.
I guess so. Well, again, if any of you all have any questions at any point, please, please, please do not hesitate to ask, because this is going to be the final opportunity. And you are in a virtual room right now with all kinds of expertise. Teachers, you got Lou, you got me. We're all on your side. We're all pulling for you. And I know you all are going to be successful. So with that said, let's take a look at some sample responses from the 2020 mock exam that you took just a couple of weeks ago. Now, I know a lot's been going on, so I do want to give you a little bit of a refresher of what these questions are as we start referring to the actual responses that we are going to look at. So, first question we're going to look at is the qualitative quantitative translation question. So, Kyle, what is the qualitative quantitative translation question? Well, I think that was a good question. Thank you for asking. This is a question where you are going to be expected to explain, of course, on the actual 2020 exam, this is going to be a question where you're going to be provided some type of mathematical equation. You're going to have to explain the mathematical equation, how that relates to the scenario under consideration, but it also is going to require that you try to conceptually explain what's taking place as well. So even though this is not going to be exactly, even though this question is not exactly what you're going to be expected to do on this year's exam, keep in mind, we're looking at the responses, we're looking at how the points are awarded, and we're looking at the quality of responses that you need to provide in order to maximize your points. So, qualitative, quantitative translation question. This is the long free response question. We've got a block that is connected to a spring. We are going to take that block, we're going to compress that block from a position of x equals 0. We're going to push that back to a position of x equals negative d. We're going to release the block from rest. That block is going to slide from x equals negative d to x equals 0. The spring is going to push that block. Then that block is going to separate from the spring, and it's going to slide until it stops at a distance, or we can say a position of x equals 3d. So the item parts here are as follow. We've got this graph of energy as a function of position. What we need to do is we want to sketch the kinetic energy of the block and the potential energy of the block spring system as a function of the position of the block as it travels from x equals negative d to x equals 3d. So that's part AI, and that is part A double I. Then we get into this situation where the student is making a couple of claims. It's going to be up to us to determine which aspects of the student's reasoning are correct and why, and which aspects of the student's reasoning are incorrect and why. So we're going to compress that spring, not a distance of x equals d, but we're actually going to compress that spring to a distance of x or delta x, we can say in this case, of x, delta x equals 2d. And the student's going to make a claim. Okay, I've doubled the stretch compression here, and when I release the block from rest, it's going to travel to a new position of x equals 6d, where it stopped originally at x equals 3d. So part BI, which parts of the student's reasoning are correct? Please explain. B double I, which aspects of the student's reasoning is incorrect? Please explain your answer. And then part C, it says using quantitative reasoning or using equations, essentially, develop an expression for the new position of the block, express your answer in terms of D. And then this is the part where you have to integrate the qualitative aspect of this question with the quantitative aspect of this question. This goes into part D, which basically this is saying which steps in your derivation in part C confirm your answers in part BI and part BII. So that's the quantitative translation question. Now, with that said, let's take a look at the rubric for this particular question so that you can get an idea of where the points came from. So this was a 12-point question. And it says here that 1 point is going to be given for sketching either energy curve with a reasonably correct shape between x equals -d and x equals 0, with 0 and maximum values at the correct locations. Now, you don't have to sketch both curves. You just need to sketch either energy curve, either kinetic energy or potential energy of the mass spring system with a reasonably correct shape between x equals -d and x equals 0. That's going to be 1 point. Second point, for sketching two curves from x equals -d to x equals 0, but these curves need to show that the total mechanical energy of the block spring system is constant as that block travels from x equals -d to 0. So you could draw any two curves that you wanted to. That's perfectly fine. But these two curves better show that the mechanical energy, meaning the kinetic energy and the spring potential energy of the mass or block spring system is actually conserved. Third point is for sketching a potential energy equal to 0 from x equals 0 to x equals 3d. So that is this line right here. We want to make sure that that line, if that is sketched and it is labeled, that is going to earn another point. And then last but not least, sketching the kinetic energy as a linear function from its maximum value at x equals 0 to 0 at x equals 3d. So part A is worth 4 points. Part A is worth 4 points. So if you want to, for those of you who are following along with me, feel free, take a screenshot of my screen right now. Make sure that you include Lou's face right up here in the corner, because you might want to keep this rubric in view as we start going through and looking at some student sample responses. So I'll give you all just a couple of seconds to take a screenshot there. Usually I use Alt Print Screen on my keyboard, and then I'll open up Paint or I'll open up Microsoft Word, and then I will just paste that screenshot into one of those programs so that you can evaluate these student responses. Again, that is Alt Print Screen. Or Print Screen just works, but I like Alt Print Screen. It only includes what's actually on the screen here. All right, so let's look at a sample response question. And let's go sample here. All right. So here is a part A. Here is a part A. So we need to take a few moments, look at that rubric, because I can't put them both on the screen at the same time. But I want you to look at the rubric and you tell me, based on this anonymous poll that I am about to create, how many points do you think that this response would have earned on the exam that year? Now remember, part A is worth a total of 4 points. So I'm going to start the poll. It says polling is closed, so I'm about to start the poll. We've now got a poll. So you tell me, how many points is this bad boy worth? Got 13 out of 25 of you who have responded so far. Thank you for those who have responded. For those of you who are still thinking, please keep thinking. I think it's great.
And whomever gave 7 generous points is a very nice person.
Well, I think so too. I mean, this person's obviously thinking that the dots and the little dash lines that were used for aesthetic purposes deserved 3 extra bonus points. Yes, yes. But on the same token, Lou, there is an individual who gave this response 0 points. So this will give us some nice discussions.
Well,
got 14 out of 25 of you who have voted. I want to give you all just a little bit more time to get your votes in, because 14 out of 25, that's not the best percentage of participation that I like to see, but you know.
If you do not see the poll, then you need to go to the participants window and just click the little more oval, and I think it should say display poll, because I know sometimes students can't see the poll even though we see it.
All right, I'm going to give you all about 10 more seconds because we do need to move on, get to some bigger, and I don't want to say better things because this is a very good thing that we're doing, but I want to give you all the chance to vote. And I think a 72% vote percentage, I don't think that's
pretty good.
Well, you know, it beats the national average every 4 years. So I think that's fantastic, Lou. All right, I want to open the floor up. Who is brave enough on this call to explain why you gave this response the score that you placed in the poll?
I'm not sure they have their microphones available, Kyle. So.
They may not have their microphones available. That's perfectly fine too then. Well, here's what I will say then. Looks like we have 10 of you who gave 4 points here. Some of you gave 3. Some of you gave 5 and 7. And of course, a few of you gave 2 and 0. This response earned 4 points. This response earned the maximum number of points here. Don't forget about the points that we are actually awarding here. First and foremost, we have at least one curve that is correctly drawn from x equals negative d to 0. Now, in this case, both curves are correct, but it's kind of nice that we can look at this, essentially the spring potential energy curve here, and it's got the correct shape. It's not a perfect shape, but it's reasonably correct. We've got the second point because if you were to match up the kinetic energy and you were to match up the spring potential energy of the mass spring system from x equals negative d to 0, almost in all cases, it's going to show that that mechanical energy, the total energy of those two individual energies, remains pretty much constant throughout the entire situation. We've also got the line drawn from x equals 0 to x equals 3d of the spring potential energy being 0. Folks, the spring's no longer compressed. And because it's no longer compressed, it's back at its stretch length. And because it's back at its normal stretch length, then there is no stored energy in the spring. And of course, the kinetic energy is going to decrease in a constant fashion there, a linear fashion. So that did earn 4 points.
So Kyle?
Yes.
If I can interrupt here. So when it says, when the rubric asks you to sketch a graph, and I don't think there will be graphing on this year's exam, but it's still a skill that will be assessed either by reading a graph. So I would say the important things are the graphs that start and stop at the right places. Mm-hmm. And then if it's a linear graph, it should look like a line. And if it's not a linear graph, it should have the correct concavity, be either concave up or down. But no one's going to look at this and say, well, this doesn't really look like a parabola or an exponential decay or something like that. Would that be a fair assessment of the way these are scored?
I think that's definitely a fair assessment, Lou, and I think that's an excellent question because here's what they could do on this exam. And like I said, this is kind of nice from my end because I haven't seen any of the questions that have been written for this year's exam, so I'm not really sure. But if I'm a guessing person, they could very well provide some type of graph like this, and then part I would not be sketch the graph. Part I would probably state, is this curve correct? Why or why not? Kinetic energy curve, is it correct? Why or why not? Potential energy curve, is it correct? Why or why not? So then you would have to explain. So I want to emphasize to you all that, again, some of you may feel like that you may have wasted your time taking this mock exam, knowing that you're not going to have to sketch graphs. You're probably not going to have to draw any free body diagrams. but the same skills that are required to actually sketch graphs, create graphs, are the same skills needed to look at a graph that's already given to you and then make the assessment or make the determination, is this graph correct or not correct? So keep that in mind in all of these types of situations where things might seem a little different on this mock exam compared to the real exam. The same skills are going to be tested because good physics is good physics. So I think that's a great question, Lou. Thank you so much for bringing that up. Thank you. Thank you.
Welcome.
Yes. All right. So going back here, let's look at another student response. So this is going to be response. I've got them coded here. This will be response D. So let's go ahead and take a look at this student response. We often get this a lot in Kansas City, Missouri, whenever we have a chance to score these exams in person. So now it's up to you, the students. How would we score this guy? Polling.
And I don't remember if you mentioned this, Kyle, but these polling scores are anonymous. Whoops, did you restart the polling for something?
I restarted the polling. I think it opened it back up originally, didn't reset the scores. Now we've got the scores being reset.
Okay, so these are anonymous, so don't be afraid to show that you're a tough cookie or a softie.
And remember, this is only worth 4 points. For the people who gave this 7 points last time, might want to dial that back a little bit. Make sure you don't give any more than 4 points here. And as the scores are being awarded, let me ask you this, Lou. Do the teachers have an opportunity? Do they have their microphones where they can interact?
None of the participants do, but I think the teachers can unmute. So if teachers want to join in here, you're more than welcome to.
I would love your all's participation at any point that you think that you can add to this discussion. I would love that. I know your kids would. Well, they're not really kids. They're actually young adults now. They would love to hear from you as well. So yeah, we're at a 62 vote percent right now, but I'll leave this open for just a few more minutes. I know that this might be a trickier response to score. We've got 15 out of 24 of you who have scored this. Give you all about 13 more seconds. Had a private chat come in. This individual gave it 1 point. By the way, you know who you are, who just chatted to me. Thank you for sending me that chat. And I will read why you gave it the score that you gave it in just a few seconds. Thank you so much for that participation. And I need to go ahead and end this polling. So I had an individual chat to me here. I won't say the name. It says 1 point. This individual gave this response 1 point for the reasonably correct curves. I guess that's from x equals negative d to x equals 0, because that's where that point came from. That individual gave 1 point. And the chat came in 1 point for an even total energy. Even total energy. So this person is saying that we're giving 1 point because the total mechanical energy from x equals negative d to 0 is essentially remaining constant throughout that entire situation. And this is the same person that keeps saying these things. So that person is saying 3 points in total. 3 points in total. So let me actually show you the breakdown here. And by the way, once again, thank you for submitting that response. That was really awesome of you. Here's how this was actually scored. It turns out the first point was not awarded. That is the sketch one reasonably correct graph shape from x equals 0 to x equals d. So you're saying to yourself, well, I mean, it looks reasonable. Yeah. Well, it turns out that the person who graded this exam thought that that looked reasonably linear. And that looked reasonably linear, and neither curve is supposed to be linear, so that point was not awarded. But the second point was awarded, the sketching the two curves between x equals 0 and x equals d with, actually this should be negative d to x equals 0 with shapes and values that show that energy is conserved. So even though this student here gave these linear curves, mechanical energy is conserved, so that person does get that point. My favorite point, it was not earned. That's the potential energy is 0 from x equals d to x equals 3d. That was a simple point to get, but no, that person decided that, I guess maybe this person was assuming the spring was staying attached to the block. I'm not really sure. And then in a slight twist of irony here, kinetic energy is linear for max at x equals d to 0 from x equal, or 2x equals 3d. That didn't make any sense. But essentially, showing that at the maximum value of the kinetic energy, it should decrease to 0 at x equals 3d. So if these curves looked linear to the person who was grading at the time, this curve also looked linear. I don't know, looks a little concave down to me, but that's just how it was actually scored. So, turns out in that case, that response got 2 points out of the 4. But thankfully, you don't have to sketch curves. But if a curve sketch is provided to you, you should be able to argue your way whether you would think that is a linear curve or whether you think that is a concave down curve. And likewise, if there was some type of sample or some type of sample response and you were supposed to critique the graph that was drawn, you should be able to justify whether you think that curve is linear or whether you think that curve is not linear. So keep that in mind. Okay, I'm going to segue back to the rubric because we now need to go to another item part. Part B says, which aspect of the student's reasoning, if any, are correct? Explain how you arrived at your answer. Again, just to reiterate what is taking place, we're going to compress the spring a distance of 2d rather than d. And the student is saying that the block will travel twice as far to a position or final position of x equals 6d. The student reasons that since the spring will be compressed twice as much as before, the block will have more energy when it leaves the spring, so it will slide farther along the track before stopping at a position of x equals 6d. We're looking for correct reasoning here. So part B is only worth 2 points. Together, there's BI, BII. It's worth 2 points. So BI, your first point, comes from identifying that the student is correct, that the block will have more energy when it leaves the spring. That should make sense. We've compressed the spring twice the distance, and because we've compressed the spring twice the distance, there should be more energy stored in the spring once we let the block go and be released from rest. Part BII, that's also worth 1 point for identifying that the student is incorrect about the new final position of the block because the spring's energy does not scale linearly with the compression of the spring. So it's incorrect to say that the block will travel a distance or to a final position of x equals 6d. And that's what you need to identify. So if you want to take another screenshot here of this part of the rubric, I know it's a little bit easier to get through compared to the 4 points in part A, but if you want to take a screenshot real quick, that's Alt and print screen, place that into some type of program, and we'll take a look at a couple of student responses. I just got another private chat from someone. Thank you very much for the feedback. I really appreciate it. All right. Let's go ahead. I'll actually go back up to another sample. Here is BI and here is BII. So take a look here. This response, I'm going to move Lou out of the way and just kind of read the responses here. Take a few minutes. And now that you've had a chance to at least begin reading, I'm going to Launch a new poll. Remember, this is all worth only 2 points. We're going to count BI and BII together. 2 points maximum. And feel free if you want to explain your responses to me in the chat window privately, that would be perfect. I'd love to see those responses because I've been getting a few in. Kudos to those of you all who've been doing that. I think that's fantastic. %42 of you have responded. So again, take a few moments, check out these responses and try to lock in a vote. Remember, no more than 2 points. This is definitely not worth 7 points here.
And if you give it 1 point, you're guaranteed to be within 1 point of the actual value.
That's true, Lou. That's absolutely true. So
it's unassailable logic.
Of course, that may make some people commit at the 1 point mark, so they feel like that they're close to either right answer or they got it. So, yeah. All right, I'm going to give us about 10 more seconds. I'm about to end the polling. 61% of you. I did have an individual in the chat window. I want to read this person's response. This person said, I am giving this specific item part 2 points. The correct expressed reasoning is provided in both parts. And it turns out in this case that indeed BI and BII both got the 1 point because the reasoning is correct. Take a look at the first response. Since more energy is put into the spring by compressing it more, the block will have more energy. That's all we're looking for. That is all we're looking for. But the student went on to say, and thus it will move farther in the zone with friction. And they look at BII. However, doubling the compression cannot be translated into a doubling of the distance. That's really all we needed. That is all we needed to get that second point. But the student went on to reiterate that, in fact, since U is equal to 1/2 K quantity delta X quantity squared, if the spring is compressed, we'll talk about that in just a second. If the spring is compressed to delta X, then U equals yada, yada, yada. So there will be 4 times the energy, not 2 times, making the block go 4 times as far. This brings us to another incredibly important point that I cannot stress enough as you all prepare and take that exam on Thursday. Make sure, unequivocally, undoubtedly, the most important thing that you should do, even if you know physics, is make sure that if you were going to write your responses, that they are readable. And some of you are going to be fine with this. Others, you're going to really struggle with this. But you need to practice your handwriting if your handwriting is pretty poor. Because I have been an AP reader for several years. I did that for 3 or 4 years in a row. And you would not believe the amount of responses that I have seen where the handwriting was so terribly bad that I was unable to read the responses and give the responses the scores that they needed. Now, furthermore, we've got this extra element where all of these responses are either going to have to be scanned into a computer or they're going to be typed. Now, if they're typed, you're fine. But if you're going to be writing, you need to make sure that you're writing with a utensil that provides nice, bold letters. Some of you have very fine writing. I taught in the classroom. I had many of those students. I've graded the exams. I've seen a lot of those exams where the writing is so light and so fine that I cannot, again, make sense of what is actually written. So make sure that your writing is legible. Make sure that your text is clear and bold so that it's easy to see your responses. And if you're taking pictures with a cell phone, make sure that the lighting is appropriate where you don't have any glare on any of the page, but you also don't have weird shadows that are causing any type of blocking of the text that you have written. You all are part of the social media generation. You all are always on TikTok, you're on Instagram, you're on Twitter. I don't know if many of you use Facebook anymore. So I know for a fact you all take excellent photographs. So pretend that whenever you're taking these photographs of your work, pretend they would be your own selfies that you would not be afraid to show others. Of course, we're not going to post any of your work on social media, but take as much care as possible as you do this. All right. So with that said, let me go back and let me just make sure that we are staying consistent here. This is this part here. I'm jumping around a little bit. So those two parts did get full credit. So let's look at another sample response. It's easy if I do this. Okay. BI, check this guy out. We go ahead and relaunch the polling. And the polling has officially been relaunched. Got one individual who gave this 3 out of 2 points.
Very generous.
They're very generous, very. I mean, you're only reading 2 sentences here, so I will give us about 10 seconds for you to lock in your votes. All right. Let's take a look here. Most of you, 10 out of the 13 who voted, gave this 1 point out of 2. One individual did give this 0 points. Looks like one individual gave this 2 points. I can't really count the person who gave it 3 points. So let's take a look at the student response. Part BI. Since the block will be compressed more, the block move further away from the spring. Since the block will be compressed more, the block move further away from the spring. Well, I would give that 0 points because we had to somehow indicate that there is more energy in the spring as a result of that extra compression. Saying that the block moved further away from the spring, that doesn't tell us anything explicitly about the energy stored in the spring or the energy of the block as it leaves the spring. BII. The block would not move more due to more energy, but due to a greater force. The block would not move more due to more energy, but due to a greater force. Let's go back to that rubric. BII. The person taking the test had to identify that the student is correct about the new final position of the block because the spring's energy does not scale linearly with compression. Now, you don't have to use that exact language, but you do have to say something about the compression of the spring does not scale linearly or is not proportional to how much energy stored in the spring. If I go back and look at this response, the block would not move more due to more energy, but due to a greater force. That's just wrong. I mean, there's just not more I can say to it. It's just completely wrong. Yeah, there's a greater force, but there's also more energy. So turns out this response, unfortunately, got 0 points out of the 2. So most of you were generous, gave it 1, but there was one lone person who gave it 0. So kudos to the individual who gave it 0. Yes. All right, we're going to move back to the rubric now to part C. Once again, just to give you an idea of what was supposed to take place here, use quantitative reasoning, including equations as needed, to develop an expression for the new final position of the block. Express your answer in terms of D. You will not have to do this on the AP Physics 1 exam this year. You're not expected to use equations. However, it is possible that you could be given some type of derivation and you have to explain how did the student go from step 2 to step 3. Or you might be given an equation or steps of equations and something may be wrong and you may have to identify what is incorrect. It's also very possible that you will be given steps of equations and you have to explain which physics concept is being demonstrated by that particular step. But I digress. Use quantitative reasoning. Essentially, what is the new final position of the block? Part C is worth 3 points. Part C is worth 3 points. Now, getting the correct answer does not earn a point. Let me emphasize that right out of the gate. Look where these 3 points come from. Point number 1. For indicating that the final energy in the spring, which becomes the mechanical energy of the block as it reaches the rough track. So the final energy in the spring, essentially the energy stored in the spring when it is compressed, becomes the mechanical energy, or you can say the kinetic energy of the block as it reaches the rough track, is 4 times the original energy in the spring. So we got to have some statement there that the final energy in the spring is 4 times the original energy of the spring. Point number 2, for indicating that the frictional force is going to remain the same in the new case and in the old case. Some type of indication. Then point 3, for equating the initial energy in the spring to an expression that shows that the energy dissipated by friction is proportional to the distance the block slides down the rough track. Now, in terms of equations, where do all 3 of these points fall into this example here? Look at the first point. For indicating that the final energy in the spring is 4 times the original energy. Take a look at this first step in the equation. U1, so we're going to probably say that's the old case, is 1/2 kd squared, and U2 is equal to 1/2 quantity 2d quantity squared. So if a student just wrote this and wrote nothing more, that would earn 1 point because it's implied that this quantity 2d quantity squared, that's going to be 4 times greater than that quantity. But it's also true that if a test taker wrote that, that would also earn 1 point. Okay, look at the second point. For indicating that the frictional force remains the same in both cases. Where is this frictional force? Well, this W1, that's work 1. That's essentially saying the work done on the block as it slides across the surface. That's the frictional surface. Or we can say that's the change in kinetic energy of the block as it slides across the surface. We can say that's the energy dissipated. It doesn't matter. That's just work 1. Notice here in the original case, the friction force is mu mg. Recall, frictional force is mu multiplied by the normal force. Well, the normal force in this case, since we're sliding across a horizontal surface, is going to be equal to the weight of the block. What's the weight of the block? It's our favorite equation, Fg equals mg. So the normal force is mg. So this quantity that I have highlighted here, mu mg, that is the frictional force. And if you notice, that is the same in both equations. So all of this could be wrong. Heck, this doesn't even have to be the right frictional force. This person could have written mu Fn in both cases, It's still the same in both cases, so it's good. The person could have written FF, capital F, subscript F there, and then capital F, subscript F there. But because that quantity is used in both sets of equations, in the new case and the old case, because it's the same quantity, that would earn that second point. And then the third point, for equating the initial energy in the spring to an expression that shows the energy dissipated by friction is proportional to the distance the block slides down the rough track. Wow, that's a mouthful. Essentially, we need to somehow have some type of expression where we're taking the initial energy in the spring, we're equating it to the energy dissipated by friction. So there's a lot of different combinations here. A lot of different combinations here. The test taker could have written this expression here, 1/2 kd quantity 2d squared, and could have set that equal to one of these expressions for like W2, like U2 equals W2. That would be fine. 1/2 kd quantity squared equals mu mg delta x2. That would be fine. That's perfectly fine. So that third point's a little trickier to get, but essentially we're just saying the initial energy stored in the spring or the energy of the block, that kinetic energy of the block as it leaves the spring, is equal to the work done by friction that causes the block to stop. All right, that was quite complicated to go through. These are always the most complicated of the type or item parts to grade on the quantitative translation, qualitative translation. So this is worth 3 points. Let's take a look at some student samples here. And I shall go to the very first one that we were looking at. This is part C. We're just looking here at this section. Let me go ahead and get the poll started. I'm going to relaunch that poll. This is worth 3 points. It's probably going to take a while to make sense of everything that's going on, so please take a look at this, see what you come up with. Just got a chat from a student who has said, I'm giving this full points because this person has earned full points on the previous parts of this sample. I mean, that's interesting logic that you've employed, but I want you to take a look at the actual sample response that's given, because I'm not going to guarantee you this student on the full question got the full points, but I appreciate your logic that you're using there. That's pretty funny. It's pretty funny. So again, first point is we essentially want to say that the new spring potential energy, or that in the new case, needs to be 4 times greater. Second point, we need to somehow indicate that the friction force is the same in both cases. And in that third point, we need to somehow equate that the energy that's initially stored in the spring or the energy of the block as it leaves the spring is equal to the energy that's dissipated by friction. %36 participation rate. We are approaching presidential election type statistics there on that one. So if some of you want to lock in your votes, you feel free to. It's like we're losing votes the farther we get in this question. You all came out hot and heavy there on the graph question, but.
I know, it's a little bit harder.
Uh-huh.
You have to read words.
I know. We got to read words and we got to look at variables and quantities, symbolic quantities. But it's exciting. This is such exciting stuff. Okay, I'm going to end this polling. 7 out of 19 participated. And here's what we ended up with. Most of you gave this 3 points. And for those of you who gave it 3 points, you are correct in this case. So where do the 3 points come from? Take a look at U1. Take a look at U2. 1/2 K negative D squared. U2 equals 1/2 K quantity negative 2D quantity squared. This is essentially implying that this new case is going to have 4 times as much energy as the old case, but that can also be seen right here as well. So, second point, we need to somehow state that the force of friction is the same in both cases. We'll take a look. I love the person who took this exam because this person actually wrote a sentence that says, and the force of friction is equal to mu multiplied by F subscript n, even drew an arrow here and said is constant. That's fantastic. That earned that second point. And then the third point, we want to equate the energy stored in the spring or the energy of the block as it leaves the spring equal to the energy dissipated by friction. Take a look here. Work non-conservative, I'm assuming that's what that means, N-O-N. Non-conservative force is going to equal 0, showing you that energy is going to be conserved because the change in the spring potential energy is going to equal essentially the change in the kinetic energy. There should be a negative sign in there somewhere, but I digress. This response right here is essentially counting as equating these two, because if you take a look, if we move delta KE to this side, we are then equating that the change in spring potential energy is equal to the negative change in the kinetic energy of the block. And that negative change of the kinetic energy of the block, that's because the force of friction does work on the block. So there's a lot of stuff written here, but notice how as we grade these exams, or as the graders will grade these exams, they're not necessarily looking at every word that you've written. They're looking at what correct words did you use as you were making your response. So go back over here. Just to be consistent with everything that we've done up to this point, I want to make it clear to everyone who is watching this video after the fact, this part C on this student sample did indeed earn all 3 of those points. So now let's look at another sample and let's check this out. I can't wait to see what the responses are for all of you on this question. Now, some of you have, I don't want to say some, one of you has sent in a chat window that you cannot make sense of what this student has written. And I will say that this is a typical response. Most responses are not as pretty or as nice as the previous response that we looked at. So keep that in mind as you, I know you're not going to be using equations, but keep that in mind as you provide your responses on the exam on Thursday. We want to make sure things make sense, things are clear, and things are following some type of cohesive narrative. Okay, I'm going to cut the vote off in just a couple of seconds, but We do have a little bit better participation in this case, so that excites me. All right. Most of you said this is worth 0 points. This is nonsensical. Why is this worth 0 points? Or why is this worth anything? 3 of you said it's worth 1 point, and somebody gave this 2 points. And it turns out that this particular response did earn a single point. Did earn a single point. So that should actually give a lot of you hope. Your responses do not have to be perfect in order to earn points. Let me make a promise to you here. As people are grading your exams, they are not looking for reasons to take points off of your score. They are not evil physicists sitting in a room trying to prevent you from getting some type of college credit for the course. In a lot of cases, they're doing all that they can to give you as many points as possible. And this is a great example of that, because even when things may look nonsensical, even when things don't seem to connect from one equation to another, there can still be some statements that are correct that can earn some points. So if we take a look here, because this did earn 1 point, the point that was actually earned is that the new potential energy of the spring is 4 times larger than in the original spring. So the question is, where do we find that? Right here. 1/2 K quantity 2D quantity squared. Unfortunately, this doesn't make any sense, but you know what? Because the test taker wrote this statement that earned 1 point. And the test taker even doubled down and has it right there. See the 4? I don't like it. It's not pretty, but it does earn a point. So keep that in mind. So you may be asking yourself, now wait a minute, I looked at the student response. I gave 1 point because it says 1/2 kx squared is equal to force times distance. I was thinking that was the point where we're setting the work done by friction is equal to the energy stored in the spring. Okay, that's a compelling argument that you've made. However, if you notice, this is not used anywhere in the response. This test taker wrote this information down, threw it on the wall, and see if it would stick. And that is a terrible strategy for this exam. Do not go into this exam thinking, I will write everything that I possibly know about this concept and hopefully I will get 1 point out of it. If you attempt to throw everything at the wall, you're not going to get the points that you're supposed to earn, because the scoring rubrics will not be designed where you just get points for just saying things that are just commonly understood in physics. This is a true statement, but it has nothing to do with the rest of the work that's shown. So don't think that you're being clever. Don't think that you're getting one up on the grader because I put it down there and by golly, it's going to work. No, it just didn't work. And there's obviously no mention at all about the force of friction being the same in all cases. So only 1 point was given there to that test taker, but that's perfectly fine. We don't need all of the points to get a 3 on this exam. And of course, we look at part D of this QQT. Explain how any correct aspects of the student's reasoning identified in part B are expressed by your mathematical relationships in C. Explain how your relationships in part C correct any incorrect aspects of the student's reasoning in part B. Refer to those relationships you wrote in part C. So this is going to be very similar. I don't want to say, definitively, but this is the type of question that you would be expected to answer on this year's AP Physics exam. The work is given. Now you explain, if we tell you that the work is correct, these equations are correct, these steps are correct, which aspects of this derivation connect in with correct reasoning, which aspects of this derivation or this calculation make a student understand that what was said was actually incorrect in whatever claim the student in the storyline has given. So if we look at the rubric here, part D is worth 3 points. For indicating that the student's correct reasoning that the block has more energy in the second situation is expressed by the calculations comparing the initial and final energies in the spring, is essentially what that is saying. So if the test taker essentially uses this equation and says that by increasing this number inside of this quantity increases the spring potential energy and connects that back in with the statement in BI, the test taker is going to get a point. Look at this second point. For indicating that the student's correct reasoning that the block will slide farther is expressed by an equation that indicates that the work done by friction to stop the block in the second situation is some factor greater than the work done in the first situation. Whew, that's a mouthful. Essentially, if the test taker can take this step right here and connect that in with the fact that that block is going to travel farther in the new case versus the old case, if this step is identified and that connection is made, we're golden. We get that second point. Then the third point, for indicating that the student's incorrect reasoning that energy scales linearly with the spring's correct compression is corrected by the expression for the initial energy of the spring. If there is some reference that this quantity D has to be squared, or that distance that the spring is compressed is squared, and that's actually highlighted with the spring potential energy equation, then we're golden there. So in a lot of cases, you can actually earn this first point here and this third point simultaneously. That's very possible. That is very possible. So with that said, let's look at a student response. 3 points. My mouse is sticking. My apologies. Here we go. I'm starting the polling now. And I'm still monitoring the chat window for those of you who were chatting with me. I appreciate it very much. %38% of you have voted. Give you all about 10 more seconds here because you only really had 2 sentences to read. All right, I shall stop the polling. The polling has been stopped. This, again, was worth 3 points. Most of you gave this score a score of 2 out of 3. And I will say this, it turns out this is a 3-point response. Now we got to find the points in here. Okay. He was right in that an increase in delta X would cause an increase in U. However, it was a squared relationship, so U equals 1/2 K delta X squared, as seen in C. So this statement right here actually earned 0.1 and 0.3 simultaneously. So that was really nice. Referred to the equation and sort of explained how that equation actually worked. And since work non-conservative equals the change in potential energy, so that's going to be the spring potential energy, equals negative mu times Fn times d, there we're relating that equation where we're using conservation of energy to actually show that that energy is dissipated. So if PE is quadrupled, D is quadrupled, so the block moves to a distance of 12D. So that's a correct response. All right. So that got all 3 points. Now it is 5:12. And we do have another question that we do need to get to. So I don't want to continue on with this discussion of this question. because we do need to move on to the paragraph length response question, which actually does move a little bit faster than these questions because there's really only one item part that we are going to look at. So a question came in from the chat. Are we expected to have a formula sheet, or can we get full points with only the info that is provided on the exam? I think that is a pretty good question. I'm not really sure exactly what you mean, but I think I know what you mean. There will be a formula sheet that is provided that will always be provided on the exam. And essentially all of the information in terms of equations that you will need to use will be on that formula sheet. Now, that's not to say, as if you all have had a chance to look at the release 2020 free response questions, it's not to say that in the actual exam question that an equation will be thrown at you that maybe you're not familiar with, and the question will be, is this a plausible equation? So that obviously won't be on your equation sheet.
And Kyle?
But go ahead.
I'm sorry to interrupt you. Why, if you don't mind releasing your screen, I'm going to share mine for just a minute because then teachers and students, the College Board has made this available, and I'm just going to show you. So Kyle, if you'll release your screen, perfect. And I'm going to share mine if I can find it. That looks right. Can you see this?
I can see it.
Okay, so this is the College Board's AP Physics algebra-based information page, and it's got the test date and times. And then right down at the bottom here, they've got the AP Physics table of information and formulas, and you should definitely have that available. I would suggest not just in an electronic copy, but you might want to print that out as something that you'll have right by. And it might be good to have a textbook or two handy, but I don't think you're going to have time to look at that. So do make sure you have that table of information. Remember, this is an open note and open book exam, but no chatting, no collaborating. So, but that would be certainly some of the resources that you should have available. I'm going to release these and let Kyle get back to question 2.
Well, and let me ask you this, Lou. You had mentioned to me in an email that there is some type of study guide that will potentially be released on the website that you all are running for Advanced Kentucky. Is that true? I
did not for, if you'd like to generate one, I have one for chemistry, but I'm not an expert in the physics curriculum. So I think the curriculum framework does a pretty good job. I know not all of it is going to be assessed on this year's exam, but I don't think there's one that I know of. Okay, because I will say this, if you all can see my screen, I did create a document that I can give to Lou. And we will post that on the KYAP 2020 website if you are willing to share that, Kyle. Yeah, I can share that. Obviously, I won't be able to share the student sample responses, so this section will be gone. But one thing that I want to let the students be aware of and the teachers, I actually worked out the 2020 sample exam questions, question 1 and 2. And I actually did it in 2 different ways. I did it in a way where I uploaded my own document. I used my own handwriting to show you all an example of providing a clear response so that the graders can actually read your handwriting and understand what you're saying. And these go along with a video that was released officially by the College Board a couple of days ago where Greg Jacobs, no, I don't believe it was Greg Jacobs. I think it was Josh Beck. I believe he went through this first question. But I also have in a digital format, and I've also got the video here linked on the study guide. In a digital format, I've actually got responses for sample question number 2. And we all work things a little bit differently, so don't be intimidated by the fact that I did use equations in this response. So I'll get that to Lou. I at least wanted all of you watching this video, part of this, who are here live, to be aware that this will be posted. You can use this to help you study for your exam, and teachers, you can use this to help go over any of those sample questions with your students. Lou, I will email this to you immediately after the meeting. Terrific. Thank you, Kyle.
Yes, you're very welcome. All right, so we'll go back to the free response questions. We had our second question. This is the classic pumpkin hanging from a rope question. We're going to shoot an arrow to this pumpkin, and this arrow is always going to travel to this pumpkin with a speed of v subscript 0. But one of three things is going to happen. The arrow is going to be embedded in the pumpkin. The pumpkin is then going to swing up to a particular angle. The arrow is, another case, going to pass through the pumpkin, but the pumpkin will still swing up a certain distance. Or if we have a certain type of pumpkin, this arrow is actually going to bounce off of the pumpkin and not penetrate the pumpkin at all. So part A says, rank the three angles: theta embedded, theta pass, and theta bounce from greatest to least in the spaces indicated below. And then in a clear, coherent, paragraph-length response that may also contain figures and or equations, we want to justify our ranking. Here's what's really exciting if we take a look at the rubric that has been released here. Part A is worth 0 points. So for all of you all out there who have been excited about having some type of ranking task or having some type of item where you just have to write things down or place a check mark or a checkbox, those types of answers never do receive credit as of late on the AP Physics 1 exam. I'm not saying that it's not possible this time, but historically, you're not going to get points just for checking a box. You're going to get points for explaining yourself. So this paragraph length response question is worth a total of 7 points. So this is going to get kind of tricky as we look at these student sample responses. The first point is going, you might want to take a screenshot of this, by the way, as I go through this. The first point, there needs to be some reference to the use of the conservation of momentum. But you can't just throw conservation of momentum up on the wall. You have to be able to somehow show how this applies to the situation under consideration. That's the first point, a reference to conservation of momentum. Second point, correctly stating or implying that in all three cases, the magnitude of the change in the horizontal momentum of the arrow during the collision equals the magnitude of the momentum gained by the pumpkin. Wow. Okay. Long story short, this is saying that the momentum lost by the arrow is going to be the momentum gained by the pumpkin. That's conservation of momentum. 3, for a valid argument explaining why the bounce arrow must transfer the most momentum. That's a very ambiguous, vaguely written point, but if you're able to explain using physics why the bounce arrow transfers the most momentum to the pumpkin, you will be able to earn that point. For example, think about it. Here's the pumpkin, here's the arrow. This arrow is traveling this direction with a certain amount of momentum. If it bounces off, we can almost imagine that this arrow is going to somehow change direction and then bounce back the other way. For momentum to be concerned, this pumpkin is going to have to gain enough momentum to not only offset the momentum of the arrow going in this other way, but the pumpkin is going to have to also have additional momentum that is essentially the initial momentum of the arrow as it was traveling in its original direction. That would be an example of how to earn that point. Look at the next point. For stating that the pass arrow ends up faster than the embedded arrow, or the pass arrow does not transfer as much momentum to the pumpkin immediately after the collision than the embedded arrow. Next point. For indicating, regardless of the conclusion about whether the pass or embedded arrow ends up going faster after the collision, that the arrow that slows the most during the collision will end up transferring more momentum to the pumpkin. So out of the pass or embedded arrow, the arrow that slows down the most will transfer the most momentum to the pumpkin. 6th point. For an explicit or implicit correct justification in terms of energy conservation, that the angle reached by the pumpkin is related to the speed of the pumpkin just after the collision. Long story short, the pumpkin that has the greatest amount of kinetic energy is going to swing up to the highest point because of that kinetic energy being transferred to gravitational potential energy of the pumpkin Earth system. Then my favorite point, a logical, relevant, internally consistent response that addresses the required argument or question asked. Don't throw things to the wall. Don't throw everything in the kitchen sink to the wall. Your paragraph has to be logical, so it has to flow. It has to be relevant to the question under consideration. Even if everything you say in the paragraph is correct, it's got to be relevant. And it has to be internally consistent. Don't say something happens in one part of the paragraph length response and then later on say something that contradicts what you said earlier in the response. So hit your Alt Print Screen button, take a screenshot of this rubric because we are about to look at a sample student response. That is the rubric, and here is that sample response. I'm going to have to zoom out a little bit. My apologies. Hopefully you can still see it. I'm going to open the poll here. This is going to be worth 7 points. 7 points. It's going to take a while for you to read this. I understand and I know, but go ahead, take your time and read it like there's no reason why you should be submitting your polling response right now.
Wow, we got some good readers, some quick readers.
I know they belong in Kansas City, Lou. We could actually use them to help grade some student sample responses. I think that would be fantastic, these quick readers. Take about another minute and 30 seconds, please. Take about 50 more seconds because I know this is a lot to process, especially this response here.
And you may not get it exactly right. I know I didn't.
It's okay if you're 1 point off. I will forgive you. Not that I'm the one who can bring any kind of judgment anyway. I guess I'll still forgive you for it.
For the teachers still here, I would absolutely encourage everyone to get on the list to become an AP reader. And this year it's going to be done online. I can't promise it will be done online in the near future, but eventually I'm sure it will be. I know one of the problems is leaving your family and your home for a week, and not everyone can do that. But more opportunities will open up in the coming future.
And for the teachers, I know that they are still actively looking for people to score these exams, so this would be the perfect time to get involved. All right, I'm going to close the polling down. Most of you gave it 6 points. Somebody gave it 1 point, and one person gave you 1, but it looks like the majority of us were either at 6 points or 7 points. And it turns out that in this case, this response did indeed earn a full 7 points. A full 7 points. So let me explain where all of the points came from. Because at this point, you may be asking yourself, why are we just grading these responses? I'm not going to be the one grading the responses. I'm going to be the one taking the test. So why am I grading responses? The reason for that is you need to see examples of the types of responses that get full points versus responses that don't get full points, so that you're aware of what you can do on your own exam to get the points that you need to maximize your score on the exam. So point number 1, how conservation of momentum applies to this situation. Well, folks, this is a beautiful response in terms of this first section here. Since the arrow pumpkin rope system is isolated, the momentum is constant. So number 1, for an embedded arrow, here is the equation for the collision. And notice, this is kind of nice. That's actually a collision in which the arrow sticks to the pumpkin. So that is your inelastic collision. Look at number 2. For the pass arrow, momentum here of the arrow is equal to mva plus mp times vp prime. Take right as the positive direction. So this is showing that for the pass arrow, the arrow and the pumpkin are both going to be traveling in the same direction after the collision takes place. And then look at that third response. Now there's that negative sign. That arrow is going to bounce backwards compared to the direction that pumpkin travels. Look at point number 2. Essentially, the momentum loss of the arrow is equal to the momentum gain of the pumpkin. So take a look at the response. In each equation, the initial momentum are the same. In equation 3, the momentum of the pumpkin is bigger than the system's initial momentum, so the pumpkin's velocity is the biggest. So between equation 1 and 2, the final speed of the arrow in 2 is bigger than 1. So I'm getting a little bit ahead of myself. But essentially what this test taker is showing by including these negative signs here is that even though the momentum of the arrow is the same in all cases, that momentum is going to be spread between the arrow and the pumpkin after the collision. And depending on the negative sign or positive sign that's used, or in the case where the pumpkin and arrow are together and stick, we have different situations. So I think that's very important, that was a very nice way to show that the momentum gained by the pumpkin is equal to the momentum lost by the arrow during the collision. Explain why the bounce arrow transfers the most momentum to the pumpkin. Well, in this case, this is very implicit because it did say that you could use equations to justify your ranking. Because if we think about this being a particular number, by this quantity being negative, this quantity here, this quantity is being the momentum of the arrow after the collision, because this is negative, this quantity is going to have to be positive to offset this quantity, but then it has to have an additional positive amount so that it's equal to this quantity here. So by using equations, which is still fair game on this exam, I'm not saying you have to use them, but they are fair game. By using equations, that is the justification for why the bounce arrow is going to be the situation where the most momentum is transferred to the pumpkin. Fourth point, the pass arrow is the fastest after the collision. Take a look at this sentence. Between equation 1 and equation 2, the final speed of the arrow in 2 is bigger than 1, so the pumpkin's final velocity in 2 is lower than 1. So that is a sentence that goes along in conjunction with equations 1 and 2, and in a similar argument to sort of explain why the pass arrow is the fastest after the collision. Again, using the vectorness of momentum, using these positive and negative signs here, really backs up this argument here that indeed the pass arrow is going to be the fastest after the collision. Point number 5, the arrow that slowed the most transfers the most momentum to the pumpkin. Essentially, it's the same type of argument here. Again, it's going back to these equations that were used, and because these equations use positive and negative signs, that same argument that I was providing earlier here applies up here. If this is a positive quantity and this is still a positive quantity, then this quantity can't be as big as this quantity. It has to be whatever this quantity is, subtract this quantity for that. But I'm getting very mathy here, and I don't necessarily want to go down that road any further. Point number 6, the greatest pumpkin speed will result in the highest angle. Since the mechanical energy is conserved, the kinetic energy of the pumpkin transfers the gravitational potential energy. So the pumpkin with the greatest velocity will swing higher, and therefore the pumpkin will have the biggest angle. And then, of course, point number 7, the logical, relevant, internally consistent paragraph. This is all consistent. This is all relevant. Test taker did not make any statements in this response that contradicted any statements that were made beforehand. So this is a 7-point response. And likewise, on the study guide that you'll be able to download later, pay a lot of attention to my responses that I have provided so that you can also see how to be very clear in what you're trying to communicate to the person grading the exam. Okay. I can show you another sample here, but we are at 5:33 p.m. And even though this session is supposed to last for 2 hours, I do want to provide you all with the opportunity to ask me questions specifically about the exam, specifically about how to maximize points. I want to provide you all an outlet so that you all have time to get all of your questions answered so that you feel most comfortable to take that exam on Thursday. So that is a good example of a student response, but do any of you all out there using the chat window have any questions for me, any questions for Lou? Do you all have any questions for your teachers who are in attendance right now?
Kyle, I think that was pretty thorough and very helpful. I think that seeing, I think there's a fear that, oh, I'm going to take AP college physics, I'm going to have to memorize equations and plug in numbers and be lost in an algebraic morass. And I love the AP physics course and the exam because it really asks you to explain, and it's not an algebra course, it's not a math course. Not that there's anything wrong with math, it's quite useful, but it really kind of gets to the heart of using physical concepts like momentum and energy and distance and acceleration. And I think being precise in language is so important, and that this is a terrific course that students can prepare very well for.
Yeah, I think so too. And I think what really needs to be kind of driven home at this point, and it kind of goes back to what Lou was saying, is it's all about communication on this exam. It's all about communication. Whenever you're writing a sentence, I know this seems very elementary, but make sure your sentence is complete. Make sure that whenever you have a thought in your head about whatever phenomenon you're studying or for whatever question that you're trying to answer, make sure that you're able to take all of the information in your head and be able to communicate it onto the page. Don't assume that the person grading your exam knows what you're talking about, because even though the grader will always try to find as many ways to get as many points to you as possible, there is this black and white line where they can't make assumptions for you. So if you start writing a lot of your sentences in shorthand, or you start using variables or symbolic quantities that you've not defined elsewhere in the question, it can sometimes become very difficult for the person grading your exam to make sense of what is taking place. Now, like for example, in this case, I can infer that this M by itself is the mass of the arrow because this is the same in all cases. I can also infer that MP is the mass of the pumpkin. I can infer that. But notice that this is a VA, so arrow starts with A. I can infer that, but that's not necessarily going to happen for every single question. This person just happened to choose quantities, symbolic quantities, that make a lot of sense with the situation under consideration. But don't go crazy. Don't just, like if this just said MV, then big MV, and then this was a small m and that was a small v, it's going to be a whole lot harder for us to make sense. Of course, I say us, I'm not going to be grading your exams, but it's going to be a whole lot harder for people to make sense of what you're trying to communicate. And I must say, based on experience, the most challenging aspect of this exam is that disconnect between what you know in your head and what you put down on your paper. And you've got to get over that bias that you have, that because you know what you're saying in your head and because you know what you're saying on paper, that does not necessarily mean that somebody else who reads your response is going to know what was in your head or is going to know what you're trying to write on paper. So make sure that you write in complete thoughts. Don't leave any thread left dangling. Make sure to close all loops. If you introduce a topic, make sure that you find some kind of closure for that topic. Don't use fluffy language. Only write what needs to be written. But most importantly, don't contradict yourself later in a question if you've made claims or provided evidence and you've explained with reasoning that you've made earlier in the question. Don't ever try to contradict yourself, because it is possible if you contradict yourself, you'll end up losing the point that you would have otherwise gained by not contradicting yourself. So communication is key, and it is even more so on this exam because you're typing and writing and not expected to use equations. You've just got to make sure to hone in on those communication skills.
And I think that this is a good time for a quotation from a pretty good physicist named Albert Einstein, who famously said, should make everything as simple as possible, but no simpler. And I'll think you guys have shown amazing stamina. Best of luck. I think you'll do terrific. And it's been our pleasure with Advanced Kentucky. I think I speak for Kyle. No, I won't speak for Kyle. Kyle, speak for yourself.
Well, I want to appreciate all of the students who were able to participate today. I once again want to thank the teachers who were here. I know that you may have shown up to try to learn something, but most importantly, you're showing up to support your students who are a part of this virtual session. So I just want to say, speaking for me, I really appreciated doing this, but I also want to speak for Darren Holt. I want to speak for Chad Rader, who have been guiding you through along of the content review sessions. I think they've done a phenomenal job. They are excellent and experienced teachers who work with Advanced Kentucky, and I know that they've had a wonderful time working with each of you all throughout this strange and weird time that we're currently living. So Lou, I appreciate you for allowing me the opportunity to share a little bit of my knowledge with all of the students and teachers who are able to come today.
Thank you, teachers and students, and we are looking to get more voices out there. So I will leave you with that, and have a good evening. Students, good luck in 3 days, and we'll like to hear from you. Take care now, and again, we'll record this or we'll post the recording and some supporting material from Kyle on our website. Take care now. Bye-bye.